Hello. Now we are going to look at complex identities. And to begin with, we're going to remind ourselves of how complex numbers work. So if z is a complex number, it has a real part, which I've labeled a, plus an imaginary part, which is the stuff involving I. So anything that doesn't involve I is real, anything that does have an I in it is imaginary. And I, in this definition of a number, is the same as the square root of -1, and a consequence of that, if we square both sides, I squared is the same as -1. So how do we do identities? Well, identities is really just saying if two complex numbers are equal to each other, then the real part must equal the real part, and the imaginary part must equal the imaginary part. That's really all we're going to do. So if I have the complex number 12 minus 3i, and that's equal to some unknown complex number, a plus bi, well, the real part is 12 in the first number, and the real part is a in the second number. And for the imaginary bit, the imaginary part is -3, and the imaginary part is b. So the real part must equal the real part, and the imaginary part must equal the imaginary part. That's all we're going to do. So 12 must be equal to a. The real part must equal the real part. And separately, the imaginary part, -3, must equal b. So the imaginary part must equal the imaginary part. That's really all we're going to do. So if we take a slightly more complicated example here, we have 16 plus yi is our first complex number, and that's equal to 2x plus 6. So we label our real parts and our imaginary parts, and then we're going to equate them. So our real parts are 16 on the left-hand side for our left-hand side complex number, and all of this has no i's in it. This has an x in it, but it has no i's. So all of that is just real. So this is the real part, this is the real part, and then we go to the imaginary part, and we have on the left-hand side we have y, so y is imaginary, but here we have nothing involving I. Well, how do we say nothing in maths? We say 0 of something. That means we have 0i. The imaginary part of our second number is 0. So we can now write that down. We have the imaginary, or the real part, we'll do first. 16 must be equal to 2x plus 6. The real part equals the real part, and the imaginary part equals the imaginary part. So immediately y is just equal to 0. But we can do a little bit more to find the value of x here. We just rearrange this equation. This is now just a standard equation. We solve it like we would any other. We want to get x by itself. So -6 from both sides, and I end up with 10 is equal to 2x. I want to know the value of x, so I divide by 2, and x must be equal to 5. Or 5 is equal to x, which means the same thing. We can get a more complicated situation here. It works exactly the same as this situation, but we have to do a little bit of tidying up before we can equate real with real and imaginary with imaginary. So what we're going to do here is multiply all of this up on the left-hand side and simplify it, and then we're going to say that it's going to be equal to the stuff on the right-hand side. So we just multiply out our brackets as we normally would. So we have 3 of this bracket, so we have 3 2x's and 3 minus yi's. So we end up with 6x, 3 by minus yi would be minus 3yi. I times 4 would be 4i, and I times 5i would be 5i squared. And immediately I see an I squared, I know that it's the same as -1, so I need to do that substitution. That's all still equal to 13 minus 8i. So I have 6x minus 3yi plus 4i, and I know that I squared is going to be -1, so I do that substitution. And now I can see my real parts and my imaginary parts, so I'm going to gather up my real parts. That's real. and that is real. And then my imaginary parts I'm going to gather up as well, so that I can equate the imaginary on the left hand side to the imaginary on the right, the real on the left to the real on the right. And I have 6x, I have plus 5 by minus 1 would be minus 5, and I have my, I'm going to put this in a bracket, gather all of my I stuff up together, so I have minus 3y plus 4, and all of that is stuff involving I. So I've taken out the factor of I effectively. I've gathered all of my I stuff together. So I have 13 minus 8i. And now I can gather up, now I can equate, I should say, my real parts and my imaginary parts. So I have my real over here. My real here is going to be the same as, must be the same as the real part over here. And the imaginary part on the left-hand side must be the same as the imaginary part on the right-hand side. If those numbers are equal, the real must equal the real, and the imaginary must equal the imaginary. That gives me two equations. 6x minus 5 is equal to 13. And separately, it gives me the imaginary parts must equal on both sides. 4 is equal to minus 8. Be careful, our signs matter, so the imaginary part here is minus 8, so the imaginary part here is minus 8. That gives me two equations that I can solve. I just solve them as I would any equation. So I have 6x is equal to 18, divide both sides by 6, and x would be equal to 3. You can do the same thing here, minus 4, because I want y by itself, I don't want that 4 units there, minus 3y is equal to minus 12, divide both sides by minus 3, and y is going to be equal to 4. And we can also get situations here where we have the letters we're looking for even more mixed up with each other. So let's try and do what we have been doing so far and see what we end up with. So we have the real parts and the imaginary parts reasonably separable. We have, or separated, we have all of this stuff doesn't involve I. So all of that is real. All of that is real. So they're going to be equal to each other. And the imaginary stuff, we have the 2b on the left-hand side, and we have this stuff over here on the right-hand side, the a minus 12i. So all of that is imaginary. All of that is imaginary. So they're already tidied up. We don't have to do the multiplying out we did here. So we can equate real with real and imaginary with imaginary. And let's see what happens when we do that. We end up with 2a plus 10 is equal to 4 minus 2b, and we end up with 2b, imaginary part there, is equal to the imaginary part here, a minus 12. But these equations I can't solve by themselves. So I have two equations and I have two unknowns. I have two equations involving a and b, and I have two unknowns, a and b. So if I have two equations and two unknowns, a tool that I know for dealing with that situation is simultaneous equations. So when I recognize that I have two unknowns and two equations involving those two unknowns, I'm just going to use simultaneous equations. Even though we're doing complex numbers, all of the tools we know from algebra still apply. So we're going to rearrange this to look more like our normal simultaneous equations. We're going to get the a and the b on the left-hand side and the numbers just on the right-hand side. That's just for convenience to make it look more familiar to us. So we rearrange here. I don't want that a there. I want the letters on the left-hand side, and I want the numbers on the right-hand side here. So I can rearrange everything and end up 2a is equal to minus 6 minus 2b. And here I have minus a plus 2b is equal to minus 12. So that equation is now as I want it. I still have a little bit more rearranging to do here. I don't want that 2b on the, or minus 2b on the right hand side. I want my a and my b over by themselves. So I have 2a plus 2b is equal to minus 6. So I have an equation with a and b on the left hand side and a number, and I have a second equation like that. So now I'm in a position to do my simultaneous equations. So I'm going to try and add these two equations together so that one of the letters adds up to 0. And I can see I have 2b in this equation and 2b in this equation. So if I took those two equations away from each other, I'm going to call this equation 1 and equation 2. If I took equation 1 away from equation 2, then I would end up with the b parts adding up to 0, and I'd end up with an equation only involving a. So that's what I'm going to do. I'm going to take equation 2, and I'm going to take away equation 1. So if I write that down, I have equation 2 is 2a plus 2b is equal to minus 6. And I want to take away this equation here. So minusing minus a would be plus a. Minus 2b would be minus 2b. That's what we want. We want plus 2b minus 2b is going to be 0b when we add them together. And minusing minus 12 is the same as plus 12. So now I can add those two together. Add them together. And I'm going to get 3a's is equal to, we get 0b, so we don't have to write that down, and minus 6 plus 12 is going to be 6. So 3a is equal to 6. I now have an equation I can solve, because it only has one letter in it, so a must be equal to 2. And now I can go back and use either of my original equations to find the value of b. So I'm going to use equation 1 here. So I know that minus a plus 2b is equal to minus 12, and I now know that a is equal to 2. So minus 2 plus 2b is equal to minus 12. Minus 2 plus 2b is equal to minus 12. Add 2 to both sides. I'm just getting b now. I'm just solving an equation with only one unknown in it. 2b is equal to minus 10. Divide both sides by 2. And b is equal to minus 5. So in that way I can find my missing letters using the tools of algebra, the tools of simultaneous equations. So that's how I can equate the real parts to the real parts and the imaginary parts to the imaginary parts with complex numbers. And that is what we need for now.